words, we went with RAM, and then we found kind of how to do integrals as long as they were like triangles and circles and trapezoids. Then we found out how to integrate using any formula as long as you had the antiderivative. We learned fundamental theorem part 1 and part 2, and now 5.5, after we've learned the fundamental theorem, we're going backwards and we're finding out how to find the area under the curve, not using rectangles, but using trapezoids, the trapezoidal rule.
This is a dumb word.
Yes.
What's spicy?
That's the word of the day.
Wait,
We're having a spicy day today.
wait, so is it where every time they say the word you have to scream?
I hope not.
Spicy. Ah!
Mason, we could do SHS rules.
It's like some horror show?
What
Okay.
does that mean? Spicy?
Spicy.
Hey, I heard they have spicy chicken burgers today.
Hey
guys, 5-4. Spicy.
Okay, so we are going to approximate the area under the curve using trapezoids. You can see that it's an underestimate in these two cases. Is it always an underestimate?
It's an underestimate only when it's concave down.
Let's see. Is that an underestimate?
No.
No. Is that concave up?
Yes.
Yeah.
That's a rectangle though.
Rectangle is a special case of a trapezoid.
I know.
Where both bases are the same. I'm just making it up.
No, that's true. Is that true?
Yeah, that's what G is made. Alright, so the area, so the trapezoid rule is h over 2. Your first y, I'll call it y sub 1 plus 2y sub 2 plus 2y sub 3 plus dot 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 2y sub n minus 1 plus y sub n.
What?
Okay, so these are all your y values. You double everything in the middle except for the endpoints you don't double. Okay, so if we have, let's say, velocity and time, and I've got velocity of 0, 3, 6, 9, 12, 20, 18, 14, 16, and 17. Okay, so I did not explain what the h is. H is equal to b minus a over n. Does that clear it up? All I did was bring in 3 more letters, but a lot of you are actually nodding your head. So n is the number of subintervals. H is actually the width of each interval, so width of interval.
Should be W.
So in this problem, well, it's like the height. H stands for the height of a trapezoid, so it is technically.
Best trapezoid.
What is
What is H here?
3?
What are we going up by? We're going up by 3. We do not need this formula here. Okay, just remember, H is what you're going up by. Now, if it was an equation and we had to use a trapezoidal rule, we'd have to figure out what H is. But in this case, if it's just data like this, we know our H is 3. So it's area under the curve. In this case, the area under the curve would be its what? I mean, units. What are we actually finding here? The distance, or it might be displacement if it's negative, but in this case it's always positive, so it would be distance. So our distance would be 3 over 2 times 20 plus 2 times all of those. So I'll go 18 plus 14 plus 16, and then plus our last one is 17.
So do like are we always gonna have trapezoids that are the same length? Like will it for
That's a good question. He said H always going to be uniform through the whole problem. Actually, you'll see on the AP exam, at least half the time they'll have different size intervals. where you literally have to find the area of that trapezoid plus that trapezoid and so on. It'll say use trapezoids to find the area under the curve given the data, and you'd have to do like 1/2 base 1 plus base 2 times the height. So you could not apply the trapezoid rule if it's not uniform.
Do we, so like on a test in your class, do we have to use a trapezoidal rule, or could we just find each area of a trapezoid?
I guess I would accept either, but the rule is easier.
Sure.
Yep.
Just let me know myself.
Okay, so did anybody bother to figure that out?
Can I just ask, is
Sure.
that plus negative 2y? What is that? Whatever. Oh.
This, yeah, plus, yeah, there's infinite amount of potentially. Gotcha.
And then is that y sub
N minus 1, this is the second to last one, then that's
n minus
last.
1?
So I should have a plus.
You have a plus. And then dot, dot, dot.
And then there should be another plus afterwards, because the dots are all the other terms I did not list out.
That's right.
Okay, so let's apply to a problem without just the raw data. So we'll use trapezoid rule to find area of y equals under the curve. Y equals, I don't know, 1/2 x squared plus 1 from 0 to
5.
4. And we'll do 4 sub-ins. Oh, we'll go like this, 0 to 2. So 4 sub-ins. H is b minus a over n. So what's our h?
1/2.
1/2.
4.
Yep. Yeah, 2 minus 0 over 4, so we get 1/2, right? Which makes sense. If we're going to have 4 subintervals from 0 to 2, we have to go up by half, 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 and that'll give us our 4 subintervals. Okay, that's our h. So 1/2 over 2 is out front. Now we have to figure out our y values. What's my first y value?
1.
1. And we got that. We'll say y of 0 plus 2, y of 1/2 plus 2y of 1 plus 2y of 3/2 plus y of 2.
I don't.
But I don't understand what we're
Yes,
doing
they
with
are.
y sub.
You can't do it in your head.
1 plus 2 times y 1/2 is
1 and 1/8.
Does that
Yes,
mean
yes.
you're just putting those numbers in for x?
Yep.
Oh.
2y of 1 would be 3/2 plus 2 times 3/2 is 9/8
17/8.
Yeah, these are bad numbers.
plus 3. All right. Do I want to do this?
Absolutely
Oh.
not.
8
Distribute it.
eighths plus 18, 26 eighths plus 14 eighths, 30. Oh, I've already lost mine. Okay. Anybody have an answer? 27 eighths? That seems a little low.
That's my answer.
Oh, then we got to take a fourth one. Right. 27 eighths? Did anyone else do it?
No.
I didn't want to calculate that last
I
one.
just wanted to watch you
What
struggle.
did I do?
Alright, so this is one problem. We could actually use our calculators. The calc program where you can choose trapezoidal, because we had an equation. I want you to verify that it's 27 eighths on your calculator.
Oh,
If you had one that worked multiplying by 1/2. So we're taking this and dividing by 2, so that's the same as multiplying by 1/2, so we get 1/4.
fractions are hard.
You can put it over 1 on the bottom if you want, and then just flip it. At least 2 that I can think of in your assignment, you'll have to find like the area of a pond, or like a cross section of an airplane or something like that. And they have it chopped up into intervals like this. So just remember that your first y, I don't know if this is very good drawing. Your first y will be 0. Can you see that this distance is 0? And then this is your like your second y, and all these, and your last y will be 0. Okay, that'll grab the shape of the pond. So if this is 10, 12, 11, 9, 7, or something like that, this is going to be 0, and this is going to be 0. So you need to know how far across it is. Let's say it's going across by 5, I don't know, 4 meters or whatever. So it'd be 5 over 2, 0 plus 10 plus 12 plus 11. Oops, I forgot to double it. That's an easy fix. Plus 7, and then plus 0. Okay, so just remember to include 0 on
So where's the x-axis?
There's no x.
Where are we pretending the x-axis?
Well, you could take it and you could like squish it down to the x-axis. But all you really need to know is the heights of the bases of the trapezoid. So it doesn't have to necessarily be on the.
That's if we just knew their areas.
Yeah, you know the distances.
Or adding it up.
So if we knew that the depth of the pond on average was like 30 feet. We'll say it's a like swimming pool, 30 feet. We found the cross section, like the surface area, and if we know the average is 30, we could multiply that number times 30, and then you have the volume of it. That's in your assignment. Alright, so do we think trapezoidal rule is better, more accurate, or not as accurate as
More accurate.
More accurate.
Okay, you see that this is clearly more accurate than the ram, left ram or right ram? Okay, so it's, if we were going to compute, it would approach the actual area faster than the ram would. Is there value in knowing the trapezoidal rule, or why don't we just integrate every time?
AP exam.
Well, why would they have that on there if there really isn't a
Why
purpose?
don't you just have like infinite subintervals and that
When you-
ram is fine?
When you can't make an equation for something.
Okay, so I heard what you said. Say it again.
Well, like why can't you just like always use LRAM but just have infinite subintervals or like close, like really high infinite?
So is there a point in doing LRAM or RRAM or trapezoidal?
Maybe if you're given a set of data that's like.
That's exactly right. Yep. So if we don't have an equation, we have just raw data, you can't integrate this unless, I suppose you could find the regression of the equation, but likely the equation
It's gonna be a ton of.
is not going to be exactly going through all those points. So there is value, you have to know how to do trapezoid if you're given just raw data. Or that type of question. Alright, so that's trapezoidal. Simpsons rule is the other rule that we're learning in this section. Yeah.
So, on the AP exam, will we use our RAM and LRM and
Yeah,
RM?
it'll be on there too. Yeah. Sometimes.
Okay. Trapezoidal then.